Good morning, ladies and gentlemen, and welcome again to the course on Managed Aquifer Recharge Systems and Water Harvesting Techniques, promoted by the University of Sassari across the MAGIA project. In the second lecture, we'll talk about MAR as a climate change adaptation mechanism and MAR in semi-arid and arid areas. This is Enrique Fernández Escalante, a doctor in hydrogeology. According to the Palmer Drought Severity Index, the decline of the available water resources in the Mediterranean area will be up to 50% until the year 2100, so we'll get closer to a extreme drought situation. Why can we say that MAR is a climate change adaptation mechanism? Management schemes featuring aquifer recharge provide guarantees with respect to future water supply and also constitute an important set of climate change adaptation measures. The implementation of MAR, in combination with other integrated water resources management measures, has great potential and provides several climate change adaptation and even mitigation strategies. In the following breakdown, we can realize how effects of climate change and the problems and real impacts associated can be fought by means of MAR solutions which are able to bring down the effects of these damages, from the underground storage to the intrusion barrier. Regarding MAR and ecosystem services, MAR is adaptable to a vast variety of environmental circumstances. There are many possibilities in the Mediterranean area to face extreme water-related events. The adopted indicators will follow the evolution of these environmental factors, at least groundwater, surface water, soil, vegetation, fauna, and socio-economy. So, MAR becomes a multi-purpose tool that can carry out several functions at the same time. Some examples for indicators are MAR to palliate irregular distribution of precipitation. The indicator is the groundwater volume storage changes. For the higher phreatic level, the indicator is the reduction in energy cost. For forest management to handle extreme water phenomena, the indicator is the percentage of total run of water changes. And the last example, for the velocity of infiltration of recharged water, the indicator is the seepage rate for specific receiving mediums. The third paragraph is about MAR in semi-arid and arid areas, technological solutions and examples for North and South Mediterranean countries. There is an inventory of facilities and experiences in the Med area. We'll expose them from east to west. The first of them for the MENAS experience in Israel for desalinated seawater. The major goals achieved during more than 3 decades of study have been the conjunctive use of water from different origins for MAR, advanced techniques to reduce the total dissolved oxygen concentration, and also advances in disinfectant byproducts uses. In Malta South, an injection barrier with treated wastewater has achieved as major goals the development of a proper design for wells in saline seawater intrusion barriers and the closed circuit from the wastewater treatment plant to injection boreholes. In Brenta, Italy, where there is a MAR experience in a forested infiltration area, the major goals have been the deployment of structures to achieve a laminar flow in MAR canals and the exemplar organizational structure for the watching and control programs and protocols. In Catalonia, in Spain, in the area of the Llobregat River, The major goals have been the design of organic reactive layers, studies for the unsaturated zone, monitoring the advances, and algae removal techniques. Also in Catalonia, there is an hydraulic positive barrier to combat seawater intrusion by means of injection of reclaimed water across boreholes. In these screenshots, there is a model for chloride's evolution in the long term, year 2036, without the hydraulic barrier and with the hydraulic barrier. In the Valencian community, there is a marine security structure which combines deep boreholes and an irrigation pond. The deep borehole was drilled in a karst next to an irrigation pond for mar and to combat overflows. In Mallorca Island, there are also some examples of mar by means of over-irrigation with reclaimed water. In these ponds, there are also some floating structures and inflatable structures for the direct consumption of nitrogen and phosphorus from the plants. And also studies on interaction have been performed. Regarding mar in MENA countries, the most interesting examples are located in Egypt and in Tunisia. Most of them were gathered and exposed in this publication from UMI, Groundwater Governance in the Middle East and North Africa. One of these examples is the Medellin detention infiltration intermittent system in the southeast of Tunisia to increase groundwater storage in the wadis and in the aquifer. It is usual the combination of a check dam and infiltration wells. The system has also reactive biological filters to protect the well construction, avoiding clogging as much as possible, and also using interactive filters, as this is the case of these palm trees, to reduce the solid charge of the water to be infiltrated. As examples of mar in other arid areas have been selected the case of Abu Dhabi for underground storage. In these slides, we can easily see that if mar is possible here, could be possible almost everywhere. Also in Afghanistan, around the Kabul area, are in development new mar facilities, as for example this couple of infiltration boreholes drilled just in the center of one stagnation pond. There are some projects working on mar in Afghanistan right now. Another good example is mar in the overexploited aquifer of Ica in Peru. Water coming from the Andes is stopped and infiltrated by means of more than 800 infiltration ponds for a later use in irrigation. As additional materials, I recommend the following 7 references to improve the knowledge acquired during this lecture, reminding all the students that one extended version of this presentation is in the Maya project website. Good luck!